I'm Lacey, and today I'm going to tell you about the binomial theorem. The binomial theorem might seem a little hard if you don't know about the editable or intricate. However, there are ways you can do it without knowing anything about either of them. So binomials are basically a plus b to say squared. If you see a plus b squared, you might think that equals a squared plus b squared. However, it doesn't. Instead, a plus b squared equals a plus b times a plus b, which eventually equals a squared plus 2ab plus b squared. This might seem somewhat simple, but it takes much longer if you have a plus b to say the fifth. Because then you'd have to go a plus b times a plus b times a plus b times a plus b times a plus b. I don't know about you, but that sounds tiresome. And eventually it would get very tedious. So we're going to learn about how to use the Pascal's triangle and use this simple equation I made to factor out binomials without getting confused with this formula and still get the basic concept. So I've discovered that an easy way to put all of this would be a plus b to the nth equals q times a factorial times reversed b factorial. So q equals this line right here. Pascal's triangle is 1 at the top. Then you have nothing to add it to, so say there were zeros there. So you have ones again. And then 1, and you have to add these two ones together, you get 2. So on and so forth, you keep adding, and your pyramid becomes bigger. So, this line here, even though this is the top row, it equals the 0 exponent. And even though this row is the second row, it equals the first exponent. So, if our problem is a plus b to the fifth, we'll find n equals 5, which is the sixth row, and simply use our equation. So q, go up here, find q equals 1. I apologize, that should be an equal sign. So you find q equals 1, so 1, a factorial is 5 times 4 times 3 times 2 times 1 in this case. If it were the exponent of 3, then it would just be 3 times 2 times 1. So we use our exponent to find our factorial. So in this case, it would be a to the fifth. And reverse b factorial, which means you start at the bottom. So b to the 0. So basically there's no b. We just wrote it for this purpose. So then, next in the row, 5, a to the fourth, b to the first, or just b, plus 10, a third, b to the squared, plus 10, a to the second, or squared, and b to the third, plus 5, a to the first, or just a, b to the fourth, plus 1, a to the 0, or just no a at all, b to the fifth. So there you have it. We just factored out that binomial without even having to confuse ourselves with this problem or formula. So there you have it, and you can use that, so on and so forth, for infinitely any binomial. And I hope I was helpful and that you learned something from this video. Thank you for watching.